All right, so let's dive into some seriously cutting-edge space exploration.
Yeah.
We're talking about the Parker Solar Probe
Right.
and its recent record-breaking close encounter with the sun.
Amazing.
This thing just skimmed 3.8 million miles above the sun's surface,
Incredible.
traveling at a mind-boggling 430,000 miles per hour.
It's truly remarkable what this mission has achieved.
Yeah.
And to think this is just the culmination of a journey that began back in 2018,
Right.
when the Parker Solar Probe first launched.
It's been on this incredible journey for over 6 years now,
It has.
using Venus's gravity to slingshot itself closer and closer to the sun.
Yeah, using Venus.
That November 6th Venus flyby was the final nudge,
That's right.
putting it into that crucial orbit.
Precisely.
Okay.
That final orbit is what allows Parker to dip into the sun's atmosphere for these close encounters.
Yeah.
An oval shape, bringing it close enough for detailed study every 3 months.
Right.
It's a delicate dance between getting close enough to collect data and not getting, well, completely incinerated.
Yeah. So December 24th, 2024, a date for the history books.
Absolutely.
It achieved the closest approach to the sun of any human-made object ever.
That's right.
What does that kind of proximity actually allow us to study?
This is where it gets really interesting.
Yeah.
One of the primary goals of this mission is to unravel the mystery of the sun's corona,
Okay.
that outer atmosphere that reaches temperatures exceeding 1,000,000 degrees Fahrenheit.
You'd think?
You'd think being further from the sun's core would mean cooler temperatures.
Right.
But that's not the case.
That's always boggled my mind.
It's a puzzle.
So how does Parker actually survive in that extreme environment?
Well, it's all thanks to an incredibly innovative heat shield
Okay.
made of carbon foam.
Right.
This shield can withstand temperatures up to 1,800 degrees Fahrenheit,
Wow.
keeping the instruments safe while they collect data.
Amazing.
It's a remarkable feat of engineering, allowing us to study the sun in ways never before possible.
That's incredible.
Yeah, it's a game changer.
So what exactly are we hoping to learn from this close encounter and the data Parker is collecting?
We're looking at some pretty fundamental questions about the sun.
Okay.
We want to understand the origin of the solar wind
Right.
and how it gets accelerated to such high speeds. Think of it like a constant stream of charged particles
Mm-hmm.
flowing from the sun, influencing the entire solar system.
Right. And understanding the solar wind is critical for us here on Earth, too.
It is.
It can have a huge impact on our technology satellites
Absolutely.
and even power grids.
Exactly. Space weather forecasting is a major application of this research.
Okay.
By studying the solar wind up close,
Right.
Parker is giving us the data we need to predict and mitigate the effects of these solar storms.
So this mission has huge implications for our understanding of the sun and its impact on our world,
It does.
but it also feels like we're just scratching the surface here.
We are in many ways.
What else is Parker designed to investigate?
Another key area of study is those energetic particles we talked about.
Mm-mm.
They reach speeds approaching half the speed of light,
Yeah.
and they can be incredibly harmful to spacecraft and astronauts.
Yeah.
Parker is gathering data on how these particles get accelerated to such incredible speeds.
This is a good time to remind folks
Yeah.
just how remarkable it is that we even got confirmation that the probe survived this encounter.
I know, right?
2 days of waiting for that signal from Parker after the close pass.
It was nail-biting.
That must have been intense for the team.
Absolutely. To think it was operating in one of the most extreme environments imaginable,
Yeah.
and yet it persevered and phoned home.
Right?
Now the real excitement begins as scientists start dissecting the treasure trove of data Parker has beamed back.
That's right.
It's a goldmine of information.
I can't wait to see what they find.
Me neither. It's going to be groundbreaking.
Yeah.
Yeah, it really highlights the incredible challenges and triumphs of this mission. It's not just about sending a probe close to the sun. It's about ensuring it can survive those conditions and send back valuable data.
Speaking of survival, let's talk about that heat shield again.
Okay.
You mentioned it can withstand some seriously scorching temperatures.
Yeah, it can.
What makes this shield so special?
The key lies in its composition.
Okay.
It's crafted from a carbon composite material incredibly light yet strong enough to withstand over 2,500 degrees Fahrenheit. It's essentially a giant shadow positioned to always face the sun, protecting the sensitive instruments behind it.
So it sounds incredibly effective, but wouldn't some heat still manage to sneak through?
You're right, some heat does get through.
How do the instruments themselves cope with the residual heat?
Well, the shield is just the first line of defense.
Hmm.
Parker also employs an active cooling system, specifically focusing on those solar panels that need to be exposed to collect energy.
Okay, that makes sense. They need to be exposed to sunlight to function, but too much heat would damage them.
Exactly.
What does this cooling system look like?
Right. It's actually quite ingenious. The system uses a pressurized water solution as a coolant, circulating it through the solar panels to dissipate heat and maintain a safe operating temperature.
So it's a multi-layered defense against the sun's fury.
Right.
The shield blocks the brunt of the heat, and the cooling system takes care of the rest.
That's right, a real tag team effort.
It's a real testament to the engineering brilliance behind this mission.
Absolutely. And all of this has to function flawlessly millions of miles away in an environment where any error could be catastrophic.
Right.
It really underscores the meticulous planning and precision required for a mission of this scale.
Yeah, you mentioned that vast distance, which brings me to another point. Communication.
Okay,
I imagine communicating with a probe so close to the sun presents some unique challenges.
it does.
How does the team stay in contact with Parker?
That's one of the biggest hurdles we face. Consider this. It takes light about 8 minutes to travel from the sun to Earth. That means any signal we send to the probe takes 8 minutes to arrive, and any signal back from Parker takes another 8.
So there's a 16-minute delay in communication.
Exactly.
That must make real-time control impossible.
Precisely. That's why Parker has to be incredibly self-reliant. It's equipped with onboard sensors and systems that constantly monitor its position temperature and other critical parameters. If it senses danger, it automatically adjusts its course and shield orientation to stay safe.
Wow. So it's making critical decisions autonomously, millions of miles away from any human intervention.
It is.
That level of autonomy is truly remarkable.
It is. You could say it's a testament to the advancements in autonomous spacecraft technology. Parker truly embodies the cutting edge of robotic exploration.
So we've got this incredibly resilient probe capable of surviving the sun's intense heat and making its own decisions.
Right.
What kind of data is it actually gathering in this extreme environment?
Right.
And how is it helping us understand the sun?
Parker carries a suite of 4 instrument packages, each designed to study a specific aspect of the sun's atmosphere and the solar wind.
Okay.
One of these, called Fields, measures electric and magnetic fields in the sun's corona.
That's crucial data, right?
Yeah.
I mean, one of the big mysteries about the sun is how its corona gets so incredibly hot, hotter than the surface itself.
It is a big mystery.
This data could hold the key to understanding that puzzle.
You're absolutely right. Another instrument, Whisper, takes images of the sun's corona, providing us with visual data of structures and activities we've never witnessed before.
So we're actually getting close-up pictures of the sun's atmosphere. That's incredible.
It is. And then there's Sweep, an instrument that focuses on the properties of the solar wind, its speed, density, and composition. Remember, understanding the solar wind is crucial for predicting space weather and its potential impact on Earth.
Right, because those solar storms can wreak havoc on our satellites, communications, and even power grids.
Exactly.
So this data is essential for protecting our technology infrastructure.
Right.
What about the final instrument?
That would be IAS, pronounced ESIS.
Okay.
It's tasked with measuring the energetic particles that get accelerated in the sun's atmosphere.
Those are the tiny bullets you mentioned earlier, the ones that can be dangerous to spacecraft and astronauts.
Yes, those are the ones.
Understanding them is vital for future space exploration.
Exactly. By studying these particles, we gain insights into their origin and how they gain such incredible speeds, which is crucial knowledge for protecting future missions and crews.
It's fascinating how Parker is not only expanding our understanding of the sun, but also laying the groundwork for safer and more informed space exploration in the future.
Yeah.
It's truly pushing the boundaries of scientific discovery.
It is, and it's not a solo effort. The Parker Solar Probe mission represents the collaborative spirit of science involving hundreds of brilliant minds from NASA centers, universities, and private companies worldwide.
It's a global effort driven by the shared passion to unlock the mysteries of our closest star. It really speaks to the unifying power of scientific exploration.
Indeed. From material scientists and propulsion engineers to data analysts and mission control specialists, it takes a diverse team with a vast range of expertise to make a mission like this possible.
And I'm sure every single person involved is incredibly passionate about this mission. They're contributing to a project that's pushing the boundaries of human knowledge and potentially rewriting textbooks.
Without a doubt. Their dedication and collaboration are truly inspiring, highlighting the amazing things we can achieve when we pool our talent and resources in the pursuit of knowledge.
It's a testament to human ingenuity and our inherent desire to explore the unknown.
It really is. Yeah,
Mhm.
it truly is a global endeavor driven by a shared thirst for understanding, the forces that shape our solar system. And speaking of understanding, let's delve into some of the fascinating discoveries Parker has already made.
Okay, I'm all ears. It feels like every time we talk about this mission, there's some new
All
revelation
right.
that challenges our previous assumptions about the sun.
That's the beauty of scientific exploration, isn't it? We're constantly learning, refining our understanding. One of the most intriguing findings has been the observations of the sun's corona,
Okay.
that superheated outer atmosphere we've been discussing.
Right, it's a region shrouded in mystery, and one of the key targets of Parker's investigation. What's it revealing about the corona?
Well, it turns out the corona's outer boundary isn't the smooth, uniform halo we once envisioned.
Right.
Parker has revealed it's surprisingly wrinkled with distinct spikes and valleys.
Wow, wrinkles in the sun's atmosphere. That's not something I ever pictured.
No.
It sounds like looking at a cosmic ocean with waves frozen in time.
It's a really interesting visual.
What's causing this unexpected texture?
That's a question scientists are actively investigating, and Parker is providing some crucial clues.
Okay.
It seems these wrinkles might be linked to the complex magnetic fields that permeate the corona.
Ah, the sun's magnetic field, a powerful force with a far-reaching influence.
Yeah.
We're talking about the force behind sunspots, solar flares,
Right.
and now potentially shaping the very structure of the corona.
Precisely. It seems the sun's magnetic field is far more dynamic and influential than we previously understood, and Parker is giving us a front-row seat to observe these interactions in unprecedented detail.
Amazing how these findings are painting a more intricate and complex picture of the sun. What other secrets has Parker unearthed during its close encounters?
Well, remember those zigzag patterns in the solar wind we called switchbacks?
Oh, yeah, like cosmic traffic jams.
Exactly, those sudden shifts in the wind's speed and direction.
Right, they always seemed a bit puzzling. Has Parker shed any light on their origin?
It has. Parker has actually traced the origin of these switchbacks to the sun's visible surface, the photosphere.
Okay.
Imagine jets of energy bursting from the sun's surface, leaving these distinct fingerprints on the solar wind.
So these switchbacks are essentially carrying information from the